Today we're going to be dealing with the surface area and volume of spheres. We're also going to be dealing with hemispheres. So let's go ahead and take a look at what a sphere looks like. So there's a formal definition, but let's just talk about the basic concept here, guys. This is a ball. That's all we're talking about. They call it a sphere. It happens to have a formal definition that says if you take one point, the center, and you go equidistant in every direction, then you get a sphere. Okay? Now, spheres are named by their center. So in this case, this is called sphere C. The plane that goes to the center is going to be called the great circle. It's just going to be the circle that if you cut the ball directly in half, that would be the surface that you show. That great circle is used in several of the formulas as we go forward, so you need to know what that looks like. So a hemisphere, just so you know, is going to be half of a sphere. We're going to be doing volume and surface area for that, so just be aware of that. And we already talked about the great circle. Again, it has to go through the center in order for it to be that great circle. So getting started. Now, surface area is unique because surface area uses 4 of those great circles to cover the outside of the sphere. So the formula is pretty easy to remember. 4 circles. So 4 times pi r squared. Now, volume's a little unique because we're going to be doing the radius, and that radius is going to be to the 3rd power, and we don't do that very often, almost never. So it is going to be 4/3 pi r cubed. Volume of a sphere and of a hemisphere are the only two that we're going to be learning that have that r cubed, so be very careful. So these are the 2 formulas you're going to be using, this one for surface area of a sphere and this one for the volume of a sphere. Now, surface area of a hemisphere is a little bit different than you might think. You'd think it'd be exactly half of what it is for a sphere, but it is not, because when you cut that sphere in half, you're creating a new surface that needs to be covered up, and it's one great circle. So it takes the 2 that make half of the sphere, and then the 1 that covers it up, so it takes 3 circles. So it's going to be 3 times pi r squared. That's going to be the surface area formula for a hemisphere. Now for the volume of a hemisphere, it is exactly half of what it is for a sphere. It's just going to be 2/3 pi r cubed. And that's the formula you need to use for the volume of a hemisphere.